Hello everyone, welcome to Clashing Coder. So in this video we will see the question that is question number 20 valid parenthesis. So this is a easy level question and one of the most liked question, and it has been asked for various interviews. For you can see from here it has been asking for Adobe, Amazon, Flipkart, Oracle, Walmart, Snapdeal, so many companies. So this is a really important question from the perspective of interview. So let's see how we can solve this question, and let's see the problem statement. So because it is same on the both Geeks for Geeks and the LeetCode platform, so the same code will work for the both platforms. So you can submit your code on the both platforms or on the one platform only. So let's see what is the problem statement about. So given a string s containing just the characters, you can see the characters are actually brackets. So the circular brackets, you can see the curly and the square brackets. Determine if the output string is valid. So if an input string is valid, if there are two conditions for the input string to be valid, so open brackets must be closed by the same type of bracket. So this means that if a bracket is open, that is the open bracket is curly bracket like this, so it cannot be closed by the square bracket, so it must be closed by the curly bracket only. So this is the first condition, and the second condition is open brackets must be closed in the correct order. So here we have to maintain an order. So order is actually, let me show you. So in this you can see the order is correct. So this is true, answer is true. Here you can see all the opening brackets, and the first condition, for the first condition you can check all the opening brackets are same as their closing brackets. So actually the types are same, you can see all are closed by the same type of brackets. But here if you see the order is also correct. If you see carefully, the opening bracket is if it is open then it is closed. Okay, this is open, this is closed, this is open, and this is closed. All brackets are closed in the correct order. But if you see in this example, if you see in this example, the first bracket is opening, the second bracket is closing, but it is not of the same type, so the types are different. In this also you can see, if the one bracket is open and the other bracket is open, so the other bracket that opened afterwards should be closed first. The bracket that has opened afterwards should be closed first. But here you can see the bracket which was opened first was closed first. So this is not true, so the correct order is not maintained, so answer is false. So the time constraints for this will be, actually you can see, so the time constraints are here. You can see from here it will be actually O of x and O of x, so the length of the string actually. So the time constraint for expected time constraints will be O of x. So but here you can see the constraints are for the x will be from 1 to 10 raised to the power 5. That is not much large. So let's see how we can solve this question and approach this question in an interview. So let's see. So in this example, if you don't understood what I was telling about the correct order, so actually in if this you can see this example, so it is true. So how output is true? If you see carefully, all the brackets are open. Okay, you can see this is open, then this is open, and this is open, and the closing order is actually what I was telling. You can see the closing order should be reverse of the opening order. So if opening order is this, so closing should be actually the bracket which has opened at the last will be closed first. You can see this was open at last, but it is closed first. But here you can see it was closed at the second point, and here you can see closed at opened at second and closed the second, and here you can see it was opened at first, and here it was closed at the last. So the correct order is maintained. But if you see in this example, if instead of this bracket, like this bracket, the square bracket, we have first of all this bracket. Okay, we have the square bracket and we have this bracket, and this is not there. Okay, so if you see here, this bracket is open, so this is true. Okay, this is correct. This bracket is open. Okay, this bracket is open. But here if you see here, this closing bracket is there. Yeah, it is true, but the order is not maintained. You can see it is closing, but it is not matching the opening bracket. It is square bracket. Okay, the closing bracket is this curly bracket or the circular bracket, so this is not correct. So the order is not correct. In this example, you can see again it is correct, because opening bracket is this. Okay, the closing is also this. Opening is this, then the closing is also this. Then opening is this, the closing is also this. This is correct. But if in some example you have the opening bracket as this and the closing bracket and as this, okay, so let me actually draw properly. You can see this is the opening bracket, this is the closing, and but the closing is this actually, you can see, and this is it. So this order is not correct. You can see both are not matching actually. You can see here the opening bracket is there and this is correct, but here you can see this curly bracket is open but it is closed by the square bracket, so this is not correct. So this is what our question requires us to do. So we have to return true or false if it is valid or if it is not valid. So it will print output accordingly. You can see here we have been given the function, we have to return true or false. In this also, in the LeetCode also, you have to return just true or false. So this is what we have to do. Let's see how we can approach this question now. So the approach for this question, you can see we have to check linearly whether the the string that we are given or the input that we are given is valid or not. When we traverse this string, you can see first we check this. So if it is an opening bracket, we can simply like skip it. We can like keep the count of the opening bracket. If this is a opening bracket, you can see it is okay. Now we get this. This is also opening bracket. We get this. Okay, we get this. The curly bracket actually. Let me draw it carefully. So yeah, you can see this is the let me write it only. So if the opening bracket is this, you can see, and the closing bracket other opening bracket is this. This is correct order. Okay, this is correct order. Now if you see, this is the closing bracket, so we have to match it with the last bracket. If it is the same type, you can see for this opening bracket the closing bracket is this. So yes, it is correct. So that means it can be closed. So till now our order is correct. Now we get this opening bracket, we can simply add the opening bracket as it is. You can see we can add it. So you can see now we get the closing bracket. Now if you see carefully, the closing bracket is also checked with the every closing bracket is compared or checked with the last opening bracket. You can see it is checked with the last opening bracket. So let me increase the size for this. So here you can see, like, yeah, you can see here, if now this is coming, okay, this is coming. So as we get this opening and closing brackets, so they are formed, they are opened and then closed. So we can simply remove them because we don't require them, they are validated. So now we have to check for this. So now you can see these are valid. Okay, these are valid. Now they will empty the stack or what we are using. So now you can see we have got this bracket, now we have got this bracket, so they are also matching. So we can simply remove them. Now we get this bracket, this is also opening bracket, and this closing bracket also matches, though we can remove them. But if in case we don't have this bracket, for example we don't have this bracket, so when we try to traverse the string, we have this bracket, then we have this, then we have this, so we can remove this because it has matched. Now we have this bracket square and this again square bracket, so we can remove this, it has matched. Now if you compare, we have this bracket. Now if we try to match this bracket with this bracket, you can see this is opening, this is opening, so this is true, we can see this is true. Now if you try to match this, it will cancel this bracket because this is matched, you can see fully matched. But now at last, let me draw it now. So at last, when we are having, so you can see we traverse the string, whole string, and we are saving this in some kind of data structure. So if when we are saving it in a data structure, we are removing the pairs which are formed. So this pair is left, you can see this pair is left, so that means it has not been closed. So we can be sure that this is not a correct order, so this is not a correct order, so this is not true. So otherwise, if we have like traverse whole string and our stack that we or a data structure that we are using is not empty, or it is empty, so that means we have traversed whole string and all the brackets that were opened are closed in the correct order. So that means the output is true, the result is true, that string is valid. So let's see what data structure we can use for this. So actually I have taken the name of the data structure many times, so sorry for that. Actually you would have got the idea about what data structure we will use for this, because we have to compare or like keep the count of the last element, only last element, and we have to check if we get a closing bracket, we have to check if with the last element that we occurred in the string. So for that we can use the simply the stack data structure, because stack is actually last in first out. So we will save a stack is actually this type of structure. You can see we can represent it like this. So it is actually the thing that comes before will be removed at last. You can see if the one has come here, okay, one has came here, now two has came here. If we remove or we try to remove anything, so we can remove only pop operation, that is called pop operation. So we will remove two first. If one has entered first, so it will be removed at last. So here you can see if this opening bracket has came first, so it will be removed at last after all the brackets have occurred. So this is what we will use for this operation actually. So we will be using stack data structure. So let me draw a stack and represent it. So here we have to follow for some conditions. So actually if we get a opening bracket, so if we get any opening bracket, we can simply push it. So or the push operation or the add operation in the stack is known as push. So we have to simply push anything if it is opening bracket. So this is opening bracket, you can see, so we can simply push it to the stack. Now if you see this is also opening bracket, we can push it to the stack. So now how we can validate if we have got this string, okay, this bracket. So now if you see, we can simply compare the element that we are on. So if it is not opening bracket, so we can simply not add it. So we will check if this is a closing bracket, and we will compare if the stack top, so stack top is actually the top element of the stack, so which we entered at the last. So you can see the curly bracket or the top element of the stack is this, and the element that we are on, that is closing element, is this. So that means this is matching. So we can simply like validate it. So to validate it, what we can do is we can remove the top element so we were having. So that means it has matched. So as I told you, we will be removing the pairs that are formed, so we will remove it. So now our stack will have just this element, okay, it will have just this opening bracket. So now when we occur this element, okay, this element, so it is opening, so we can simply push it into the stack. When we get this element, we will similarly do the same thing. So we will having this we are having this element. We will check if stack is not empty. Stack is not empty, it has some elements. So we will check if the last or the first the top stack top is equal to the closing bracket for this. Okay, so you can see yes, so you can see here, so this is true, the pair is forming. So that means the opening bracket that we are having in the stack, so actually we will use the stack for only storing the opening brackets. The closing bracket will obviously pop the opening bracket from the stack. That means it has been validated. So here you can see it is validated, so that means we will remove it. So we have removed it. Let me erase this. So let me make a new one. So you can see we have removed it, and now we have the opening bracket this. So now when we get this bracket, this is opening, so we can simply add it. So opening bracket, we can add it. Now when we get this bracket, this is closing bracket, you can see it is closing bracket, and we will check the stack top. Stack top is this, you can see this opening bracket. So yeah, it is matching, so we can simply remove it. So we pop it. Now when you see we have traversed whole string, and the string has is now null. So now what we can check is now our string is valid or not. So to check that, you can see if our stack is not empty. As I told you, our stack is not empty, so here the opening bracket is still there. So that means the string has not been it is not valid, it has not been balanced. So that means our output will be false. This string is not balanced, our stack is not empty. So if we were having let me this is, so if instead of this this string we were having this string, actually we were having this bracket, so then when we pop this element, we will be on this element. So we will check if this is a closing bracket. So yes, it is a closing bracket, and we'll check if the stack dot top, that is this opening bracket, it is matching with this. So this is forming a pair. So that means we will remove this element. So when we remove this opening element or the opening this bracket, we will have an empty stack. When we have an empty stack and we have traversed whole string and we have an empty stack, that means our string is validated. Otherwise there will be one more case. Let's see. So if you are having a string, instead of this, if you are let me erase this. So if you are having a string which is having the closing bracket at first only, so it is having a closing bracket at first only. When we are traversing a string and we get a closing bracket in a traversing loop, so we will check if our stack is empty and we are getting our closing string. So that means this is not validated, so this is not actually balanced. So the output will be false here. So output will be false actually if we are having nothing in a stack and we are getting the closing bracket. So we are not having the opening bracket only. So why we are getting closing bracket? So that means the string is not validated or not a balanced string. So let's see the algorithm for this. So actually the algorithm will be similar. You can see, as I told you, there will be some conditions and we will be using stack. So I have formed a stack here. You can see this is a representation of stack actually, and this is the string that we are having, and this is the algorithm actually. So first we have to initialize the stack, then we have to traverse the string. So actually I have written for I in S, so it is actually the element. So I is actually the element that we are on, it is not the index. So here we are having some conditions. As I told you, if we get an opening bracket, we will simply insert into a stack. So you can see here we got the opening bracket. Opening bracket is of three types: I is equal to this, I is equal to this, and I've written the pseudo code. This is not actually a code, this is a pseudo code, you can see. So I have not written I equal to for every bracket. So you can see if it is opening bracket, we will simply push it into the stack. So you can form a stack in C++ using the stack actually the stack, and in Python you will have to use a list. List can be used simply, you can pop at the back and the insert also at the back of the stack, that is end of the stack. So in C++ you have the stack data structure, you can use that. So I will use the stack data structure. So you can see we have pushed the element, so this element is pushed, we are on this element. Okay, this is the opening bracket, we have pushed it into the stack. So now we are having three different conditions here, you can see in this else if. So else if, as I told you, if we are having we are traversing the loop, so this loop has not ended, but we have our stack is empty. So that means we are getting some closing bracket, because if it would have been the opening bracket, this condition would have run and it would have iterated to the next element, but this is not true. So that means we are getting a closing bracket and our stack is empty, so we will return false at that point only. So you can see here we have returned false. This is condition for that false part. If our stack is empty and we don't have any opening bracket in it, so we are getting closing bracket but our stack is empty, so we will return false. This condition is for that. Now this is the main part of the code. So here you can see else if our stack is not empty. So here you can see this is true, our stack is not empty, but here you can see this part will be true in this part only. So it will be simply, it is a opening bracket, so it will be added to the stack. So it is added. So now when we get this bracket, we are on this bracket, that is this closing bracket. So we will check this condition is not true, so we'll get into else if part. So else if stack is not empty, so yeah, stack is not empty, it is true. So now we will check if the top of the stack, so if the top of the stack is the opening bracket for this closing bracket, so that means it is forming a pair, it is valid. So we will remove the top of the stack. So here if we will check if I is equal to this. So actually here you can see this is actually I've written wrong something, so let me change this. So I will just take it. So here you can see in this example, actually I like figured it out that I've written the wrong pseudocode. Here you can see if I, that is our element, is this element, that is it is a circular bracket, so this is not for true. Actually you can see this is a curly bracket, so else, this is else if part, you can see else if, else if, and this is the for the square bracket, and else if part, this one is for the curly bracket, and this will be true. Actually you can see I is this, I is actually this closing bracket, and we will check if the stack.top, so stack.top will return this element, so it will be checked with this. So you can see stack.top is this, and I is also the closing bracket for this, so that means this condition is true, this is validated. So we will remove this or pop this. Now we will like run for the next element. You can see this will be coming, so this is the opening bracket, so this will be simply inserted into the stack or pushed into the stack. When we get this element, we will check into this condition, else if stack is not empty. So yeah, stack has two elements, it is not empty, we'll get into this condition. You can see this is for the square bracket, so then it will be compared with the stack top. So if stack top is this opening bracket, and our closing bracket that we are on, the element that we are on is the closing bracket for the opening bracket, that is square bracket, we will simply pop that element. That means it is validated. If otherwise our stack gets empty in between, that means we don't have any element, so we can simply return. Here you can see if if we have this element, okay, we have the opening bracket is this, and our stack is not empty, and we get another bracket. So if our string is this, okay, our string is this, so we get this bracket. So here no condition will be true. If, else if, and else if, all the three conditions will be false, then we will simply return false. So that means the opening bracket that is circular is trying to be closed by the curly bracket. So this is not true, as we have to maintain the order. The brackets can be closed only by the same type of the brackets, so this is false, so we will return false at that point. So here you have to see for the conditions. Actually this is actually an implementation based question, so you can see you have to use stack. So here let's summarize it. Actually the time and space complexity for this will be actually of n only, because the time you're traversing the string, so it will be the size of the string, and the space will be actually n only, because we have to use the stack. So stacks take the space. So let's see again. So you can see we are traversing this element, okay. If it is an opening bracket, we are simply adding to or pushing into the stack, and else if we are checking if stack is not empty, that means we have some elements. So we will check if the top stack, the stack top is the opening bracket, this opening bracket, and the element that we are on the closing bracket for this opening bracket, so we'll simply pop that first element. And we will check for the all the three types of brackets. Otherwise, if the opening bracket is this and the closing bracket is of some other type, we will return false. So that means the string is not validated or not balanced. Otherwise we will return false if the stack is empty. Okay, if the stack is empty and we are trying to add the closing bracket, so we are getting the closing bracket but we don't have an opening bracket only, so we will return false. And we will if the whole string or this loop has not returned false, so that means our string has been traversed. And we will check if our stack is empty or not, so we will simply return s dot empty. If stack is empty, so that means our string is validated. If stack is not empty, so that means there was some opening bracket which was not closed at the end of the string also, though that means the string is not validated. And the time and the space for this will be of n only, because we are using the stack, you can see, so it will take of and time space, and the time will be of n only, because we are traversing the this string. So let's see the pseudocode, actually the code in C++. So I will show you the code in both platforms. So I will also provide the code in the description, so you can check it from there also. You can see here we have got the string as an input, that is in this function we have to simply return true or false. So here I have initialized the stack of type character, because we are traversing a string, so the elements in the string will be actually characters. So I've used the for auto loop. Here you can see for auto, so it will take automatically the type of the character it is traversing through the loop. So this is our iterator it. So we'll check if it, this is actually the opening bracket, so we can write in or in C++ also, like Python, and we can write and also in C++ if you didn't know, so you can write that also. So if it is an opening bracket, we are simply pushing it to the stack. So you can see stack dot push, it is a simple syntax that I used in the pseudocode also. Else if that means it is not an opening bracket, so it would be a closing bracket. So we will check if stack is not empty. If stack is not empty, that means there are some opening brackets which have not been closed. So we will check if this is a opening bracket is curly the square bracket, or if it is a this circular bracket. We will check if the stack top is the square or the this type is matching, so we'll simply pop that element. So that means it has been matched or it has been validated, so we'll simply pop that. If the element that we have opened it is a circular bracket and it is trying to be closed by the curly bracket, so that will alter our order, so it will return false, so that is not validated. So if our stack gets empty before anything, like before getting the opening bracket, our stack is empty and we getting the closing bracket, so we'll return false, that means it is not validated. And we will check if our stack is empty, that means we have validated our string and it is correct, so we'll turn 1, otherwise we'll turn 0. Let's see, submit this code, and not the keys for keys, so let's submit there also. So this code is similar. Actually you can see I will provide the code in the description, you can check it from there. So here you can see it got submitted, and it took just like 0.0 ms second. You can see it didn't took any time, but the space was required because of the stack. So let's see on the click for geeks. So you can see here it also got submitted. And thank you for watching, guys. Thank you for watching. Do like this video and subscribe this channel for more such videos. Thank you for watching.